Good morning, my YouTube viewers. It's Crystal here. I'm just here this morning because I wanted to go over some statistics for you in Python. And the reason why is because I'm viewing a data science video with Eureka. And what they're doing is they're going over the statistics functions in the R programming language. And because they say that the R programming language was designed for statistics. So I thought to myself, well, I only use Python. The main reason why I only use Python is because I can use it with Google Colab. Google Colab is a free online Jupyter notebook, and I'm not aware of any free R interpreters. If any of my viewer knows of a free R interpreter I can use, then please let me know. Please send me a message and let me know, and I'll try it out. But until that time, I'm going to continue using Python because Python is what I do most of my work in, and I've been programming in Python for about 2 years now, so I know a few commands. I certainly don't know all of them, but I know a few of them. And so I thought, well, even though R is a statistical programming language designed for statistics, I'll go ahead and try to convert a lot of the R functions to Python functions and do that. So that's what I've done. So the first thing that we're going to do is we're going to import our libraries. We're going to import NumPy as NP, which is your numerical computations, and it also creates NumPy arrays. We're going to import statistics, which I believe statistics is an internal library in Python. We're going to import SciPy from SciPy. We're going to import stats because stats has a little SciPy has a little stats function in it. SciPy has a little stats department in it, and so we're going to use that. And then we're going to import Seaborn as SNS, and Seaborn is our statistical graphics library. And then so what we're going to do is we're going to create a random array. So data equals np.random.normal. So 20 means 20 is going to be the base. And 1 is going to be the deviation. It's going to vary 1. And 10 is going to be how many numbers we're going to create. So we're going to create 10 random numbers. And so we're going to use displot, Seaborn's displot. So we're going to create a graph of the numbers. And if you notice here, what's really interesting is that it doesn't actually have the number 20. It has 18 to 5 to 20 to 5, but it doesn't actually have the number 20. That's missing. So that's really interesting. So the mean equals data.mean. So you can get your mean. Your mean is your average. And that's 19.34. And your median, you can get your median from the statistics module. So median equals statistics.median data, and that's 19. So median is like at the middle of the data frame. So mode is going to be an integer brackets stats.mode brackets data, and then it's going to be 0. So mode is 18. It's going to be the most common. So 18 does appear to be the most common. It's got 1, 2, 3, 4 18s. So, but that's what it says. It says mode is the most common. variance is how much the values vary from the center, and it's going to be 0.46, and that's variance equals statistics.variance data says x bar equals none. And now we're going to check the standard deviation. And sorry, standard deviation is how much it deviates, and that's st.deb equals np std data. So basically, these are all functions that I created using Python that apparently with R, because they say the R is a statistical programming language, that it's in there already. So in theory, it would be easier to calculate these functions in R than Python, because you don't have to import any libraries to do it. But I did have to import libraries to do it in Python. But what I just wanted to do is I wanted to recreate what you can do in R in Python. But what I want to do is, I think this is really interesting that there's not a number 20 in there. So it's like a normal distribution. So what we're going to do is we're going to say 1.5, and I'm going to say 100, and I'm going to run it and see what happens. So rather than 10 numbers, we're going to have 100 numbers, because the normal distribution, from what I understand, is supposed to be close to a Gaussian distribution. And so we've got our 100 numbers. So yeah, this is closer. This is closer to a Gaussian distribution, or it's definitely a normal distribution, and it's closer. So our mean is still 19.8. Our median is 19.9. Our mode is 16, which that's odd. I'm going to take out that and see what happens. No, it doesn't work. Now it's saying the mode is 15. Okay. And then our variance is 2.27, and our standard deviation is 1.5. So you can see it, and then what we'll do is we'll say make it 1,000 and see what happens to this distribution. And you can see as you increase the number of examples, the distribution gets closer and closer to a normal bell curve. So that's interesting. That's interesting indeed. So I've gone ahead and done what I wanted to do in this code review. So I'm going to go ahead and stop the video. But I want to thank all of my subscribers for supporting my channel. And if you like my video, please like, subscribe, and share. And thank you so much for watching my video. And I look forward to making more code reviews for you in the future.